Yeah, so basically in today's class, like we will start once again, a new data structure. Okay, like, in this series of data structures, we are just learning new data structure in, like till now, if I talk about last 12 to 13 classes, we have learned what is linked list. Then after that, stacks. Then after that, queues. Okay. So we are just learning new data structures. And based on the question type, we are going to apply any one of them. Now, today's data structure is going to be a little different. That is trees. We will understand why it is different from whatever we have learned till now. So, first of all, though, we will understand why there is a need to study this topic. Okay. After that, there are some standard terms related to trees, so we need to understand them as well. उसके बाद we will see the structure, कि how tree is defined in our coding language and how we can work on it. And then, of course, guys, whenever we are learning a new data structure, it's important that we know how to travel it. Because if you don't know how to travel a thing, how can you solve a problem, right? And once this is done, then we can go to some very important or standard questions that is going to be covered at the end. Okay. So, like, let's start with each and every small thing, and then let's see, okay, what is all the things related to this topic. Okay. So, first of all, though, guys, till now, whatever data structures we have studied, can you name some of them? Whatever data structures you have studied till now. Okay. Right. So let me write them. Arrays. Arrays is one data structure that we have studied, the basic data structure. Okay. After that, array list. Okay. After that, strings. Right. Now I can say stack and queue as well. Stacks and queue as well. Right. And of course, linked list. Right. Linked list also we have studied. Okay. Right. Hash map, hash set also you can include, but right now, let's write them key essay. Okay. That is also you can include, but I'm just writing some of them. Linked list I'm writing here. Okay. So linked list. Right. Now, first of all, though, I would like to categorize why I'm writing this in two line. Reason behind that is, guys, can I say all the above data structures, they are kind of dependent on arrays only. Continuous memory allocation was happening. Okay, in array, what happens if you are creating an array, so of size 5, so all the 5 elements are getting created in continuous memory of form. Okay, so that's why. And same goes for array list, same goes for strings, same for stack and queue as well. You must be wondering, ki stack is a data structure that looks like this. So, but understand, guys, this is just the viewpoint. It is once again nothing but an array in which addition is happening at this end as well as removal is happening from this end. Got the point, guys? Once again, talking about the queue, it is also nothing but derived from an array or array list only, in which addition happens at this end and removal happen at the front end. Okay. So all of these data structures, we can just write them. In them, what happens is continuous memory allocation. Continuous memory allocation. Right? The way memory allocation happens in array. Tell me, is that same thing going to happen in a linked list as well? In linked list also continuous memory allocation happens? Of course not. Okay, so not continuous, or I can say discontinuous memory allocation. Reason behind that is the only reason why you need the next pointer, because one node is getting created at some address and another node is getting created at some another address. Okay, like this. Suppose one node is getting created at 14k, another node is getting created at some 16k. Now you are joining them. 14k next, you are 16k. Got it, guys? Okay. So arrays, array list, strings, stack, queues, they are like kind of मतलब ठीक है, arrays का तो there is direct कि arrays में continuous memory allocation happens, but all these things are also nothing but they are also getting derived from arrays only. Like in if you open these classes someday, these are the classes already present in Java. If you open their code now, you will see as a data member they are using nothing but an array or an array list. Okay, like array list is definitely using an array as a data member inside its class. All these three things, they might be using an array list or they can use an array as well, any one of them. Okay, so you will see at the end we can say that continuous memory allocation happens in them. And linked list is the single topic in which we have saw this discontinuous memory allocation. Ki one node is getting created at some other address, other is getting created at some other address. Wherever space is present, nodes are getting created there, and now you are just linking them so that the linked list is going to be made. Perfect. Now the point is, does not matter whether I talk about them or them. Can I say all of these things are nothing but your linear data structure? Data is getting stored in a linear manner only. Okay, so can I say these are nothing but the linear data structure? I can call all of them as linear data structure. Correct or not, guys? Okay, think about it. In a linked list also, the information is getting stored in a linear manner. Okay, every node and its next pointer, right? Same if I talk about an array, the information is also getting stored in a linear manner. If I talk about a stack, information is getting stored in a linear manner only, guys, right? Okay, like एक line से, okay, in a same line. So can I say that linear data structure, yeah, like all of these things that we have studied till now, we can consider them as linear data structure. Now in today's class, first time we are going to learn a data structure which is not linear. Okay, right? Nikhil, a data, anything in which you can store data, okay, right? That we call as a data structure, right? Okay. So now, guys, in today's class, for the first time, we are going to study a data structure that is non-linear. Non-linear, or you can call it at hierarchical as well. Perfect. Non-linear or hierarchical data structure. Now, understand ki first of all, though, why the need of this thing? Why we are even needing a non-linear data structure? So the point here is, let's consider a general life example, okay? So suppose there is a company and I would like to draw the position chart, okay? Position of employees in that company. So can I say the main person is CEO, right? Now under this CEO, there can be different officers that can come, like COO can come, operating officer, and then CMO can come, correct guys? And then CTO can come, okay? Any other thing? Finance officer. So let's see, CFO can come. Now if I keep on growing this branch, let's go to CTO now, because we are generally familiar with CTO. So let's go to that. Under the CTO, maybe there is some vice president. Okay. Now under this VP, some managers can come. Manager 1 and then manager 2 is coming. Okay. Right. Now similarly, let's see under this manager 1, some developers are coming. For example, ST1 is coming. Then there is another person, ST2, or suppose an intern is also coming. Right. Similarly goes here as well. Now my only question to all of you is, think about this information in your coding manner. Okay. So tell me, can you store this information in a linear kind of data structure? Like, can a linked list help you storing this information? Think about it. No, that is the only problem. Okay. We need to store this data. We can't store this data in a, like linear data structure. This data is a little bit complicated, which cannot be stored in a simple data structure like array, linked list, or your array list. Makes sense? So in order to do this thing, right? Now think about more real life example, guys. So can I say that in our childhood, we used to get some holiday homework related to like create a family tree, right? Okay. By putting pictures in the tree and so on. So that is the same example. Family tree can have one of the such information as well. Similarly, can I say file manager? Okay, file system that is present in our computer, that also follows the same thing. Like if I talk about the standard file system of Windows, there is a C drive from where you start, and then C drive is storing some folders in it. Then every folder is containing some files in it. Okay, so this is also kind of tree kind of thing that we can think of, right? Okay. Now guys, in order to store this thing, in order to store this kind of information, we are going to learn a new data structure that is named as tree. Okay, so tree is going to be our first non-linear data structure that we are going to study. After that, we will see graphs as well. That is also non-linear. But right now, let's start with the trees. Graphs we are going to cover at the end. Perfect. Makes sense, guys. So are we making sense till now? Why there is a need? Whenever you want to store this kind of information, you definitely need a non-linear data structure, and tree is the first one that we are going to study. Perfect. Okay. Now with that, if the basic understanding is clear, let's try to understand some terms here. There are standard terms related to trees that we need to understand. So let's understand terms. Understanding important terms. Okay, so just a second. Okay, so suppose this is a tree that I have already created. Okay, now first of all, though, there is only a single point from where you can start, and that is known as the root. Okay, you can just understand it as the originating point. Okay, like the point from where your tree is getting originated. Now understand, real life mein what happens, guys, roots are at the end, or usme se the things grow, right? The plant grows, right? But here it is just reverse, like we are just reversing this complete diagram. Okay, so root is the topmost node of your tree, the single originating point. Okay, so I can just consider it as originating point, the point from where your tree is getting originating point. Okay, now all these circular things, we call them what? We call them nodes. Okay, the most famous name is calling them nodes. So all these circular things, right? This is also a node, guys, but it's having a name, root. So now all the circular things are known as nodes. These are the nodes of your tree, right? Now the line, this line that is connecting two of the nodes is known as what? Any guesses? Okay, like these lines, all these lines that are connecting two of your nodes, we can just call them edge. An edge is something that connects a two node. You can call it anything, but yeah, like we are just, see, name mein there is nothing, guys, but the point is ki if two people are talking, generally we talk about it in this manner, ki nodes of my tree, edge is this edge, this edge, this edge, this edge. So that's why we are just understanding these terms. Okay, right? So this is the root node, the originating point of your tree. There is going to be only a single root node, guys, right? Your tree originates from just a single point. Now these are all these circular things are nothing but nodes, and then these lines that are connecting two of your nodes are known as edges. Perfect. Okay, right? Now going with this, let's do some more definitions to understand it in even some nicer manner. So the first thing is the relation between parent and child. So parent, child. Okay, so before going to this, I would like to name my nodes. I will just name them anything so that we can call them A, B, C, or like this: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. Okay, so just two questions. Parent-child relation we need to understand. Okay, so look at this. Tell me who I like F is the parent of which node. So like if the link is like this, na guys, F to I. If the link is from F to I, that means the above thing is the parent and the below thing is the child of it. Okay. So yeah, parent child mein, it's easy to understand. I can just give you some examples here. Ki, you just tell me yes or no if the statement is correct or not. L is parent of H. Tell me, guys, is this statement true or false? Is L the parent of H? Have a look at them. Is L the parent of H? No, it's the child of H. Okay. So that statement is false. Right? Now if I talk about this, ki O is a child of M. So is that a true statement or a false statement? So O, are you a child of M? Yes, I am. Look at the link. O is the child of M. So you can say, yeah, this statement is true. Okay, so look at any link, you will get to know the above thing. Like if this link is like this, so the above thing is parent and the below thing is child. The relation is from parent to child. Got it? Okay. Now one question, the one important fact here to understand is ki every node is just going to have a single parent, guys. Okay, like a node cannot have two parents. For example, G. Who is the parent of G? C. Right? Who is the parent of L? H. So every node is just going to contain a single parent. Okay? So that's important point to consider. So I'm just writing it here. Ki each node will have a single parent only. Each node has a single parent only. So I think this relation between parent and child is clear. Okay. Now if I talk about the root node, guys, root has no parent. Of course, okay? Root is the originating point, so it is going to have no parents. Okay? So for root, the parents are not defined. So I'm going to write the point here, except the root node. Okay. Now, second thing, if this parent-child relation is clear, so second thing that we want to discuss is there is a word named as the siblings. Okay. So let me tell you what is the definition. Uske baad we will do question. Sibling is nothing but simple. It is okay. Sibling is nothing but nodes having same parent. Okay. So they are getting considered as siblings. So nodes with the same parents. Nodes having same parents. Okay. So the nodes having same parents are going to be known as the siblings. Like for example, let's understand. Okay. So tell me, are G and H siblings? Are G and H siblings, guys? Yes or no? Yes, because both of them are having C as their parent. Correct? Okay. Now, similarly, quickly tell me, are ABC siblings? ABC, are they siblings? Yes, because all of them are having root as their parent. Okay. So, ABC are siblings, right? Now, tell me, are FNG siblings? Are FNG siblings? They are not. Okay. They are like kind of cousins. Sibling is not going to be. Sibling is like, direct blood relation. Saga bhai, aisa type, right? So they are not siblings, guys. Reason being, F's parent is B and G's parent is C. Both of their parents are not same. Exactly. Okay. So they are not going to be considered as sibling. F and G are not siblings. Okay, exactly. But there is no such word like cousin in trees. So let's discard it completely. Just remember that siblings are nodes having same parents, and that's why F and G are not uh, uh, siblings, guys, because both of them are having different parents, right? Now, coming to the third point is also very easy to understand. The next thing is leaf nodes. Okay, so leaf nodes. Any guesses what it could be? Intelligent guess. मतलब ऐसे definition में there is no rocket science. General meanings are there. Leaf nodes. Okay, so imagine a tree. What happens in a tree ki theek hai, is like there are branches. So leaves are the ending point, right? मतलब after the leaves there is nothing. Okay, so exactly. Leaf nodes are the nodes with no childs. Exactly. So all these nodes that I'm circling are the leaf nodes. So leaf nodes will not have any child, like D. There is nothing to go from D. D is the endpoint of this branch, right? Now similarly of this branch, E is the endpoint. Here J, here K, G, P, Q, R. Okay, so if I draw them, D, E, J, K, G, P, Q, R. All of these nodes are leaf nodes because they have zero children. Okay, so leaf nodes are the nodes with a zero child. Nodes with zero child are known as your leaf nodes. Okay, easy. Like for example, quickly tell me, is N a leaf node, guys? Is N a leaf node? Yes or no? Think about N. Is it a leaf node? Okay, no. It is having a single child, that is P. Got it? So it's not a leaf node. P is a leaf node because it don't have any child. So the number of childs are zero. So that's why P is a leaf node. Okay. Now the next two things. Okay. I hope all these things are clear till now. The parent-child relation, siblings, and leaf nodes. Easy to understand. Right. The next thing is a little critical. Let's see. That is ancestor. Once again, a general English word. Ancestor of a node. So first of all, understand the definition carefully and then tell me the answer. Okay. So nodes coming in the path of root to this node. Right? So if you want to know ancestor of a particular node, so the ancestors of a particular node are going to be nothing but nodes coming in the path of root to this node. Nodes coming in the path, or you can just consider this as key from root to this node. Okay? Right? So let's understand. For example, let's see. Suppose I want to know what are the ancestors of M. So understand, guys. Draw a path from root to this node. And now all the nodes coming in this path are going to be considered as ancestors of M. Root, C, H. Okay? Okay, once again understand. Suppose I need to calculate the ancestors of L. Now can you help me answering that? What are ancestors of L? So draw a path from root to this node. This node is the node of which you are calculating the ancestors of. Okay, like if you want to calculate ancestors of L, so this node is nothing but L, right? So suppose I want to calculate ancestors of L. So draw a path from root to this node, and then whatever nodes are coming in this path are your ancestors, like root, C, H. These are the ancestors of L. Okay. Now quickly tell me, guys, what are all the ancestors of Q? What are all the ancestors of Q? Okay. Right? Parent, then grandparent, then grand-grandparent, then grand-grand-grand-grandparent. Okay, like this. Okay, exactly. Okay. So draw a path from root to this node. Now find out all the nodes coming in this path. So root, C, H, M, O. These are all the ancestors of my node Q. Got the point? Okay. So this is what the definition of ancestor is, right? Now the last term that we are going to study here is the opposite of ancestor, that is descendant. Descendant. Okay. Now first of all, once again understand the definition. Uske baad giving the answer. Descendant is nothing but basically all the nodes. Suppose you want to find out descendant of a particular node. So all the nodes coming under this node are known as descendant of that node. All the nodes coming under this node are known as descendant of this node. Perfect. Like for example, okay, quickly tell me, what are all the descendants of F? Yeah, what are, like Presh, general terms you must have missed. So koi nahi, just carry on from now. Koi nahi, I'll just quickly give you a recap. Okay. So what are all the descendants of F, guys? So all the nodes coming under this tree. Right, understand ki F is, like all the nodes coming under it are the family that is originating from F. So all these nodes will be descendant of F, like I, J, and K. Perfect. Okay. If I talk about descendants of root, so everything is going to come under it. Descendants of root, everything that is coming under the root is going to be considered, right? If I talk about descendants of C, so this part you need to consider, all the part that is coming under C. Correct, guys? Okay. So I hope all the definitions are clear. Okay. But once again, I want to give you a quick revisit so that each and every word is covered. I'll just ask you some questions and you need to answer me very quickly. Okay. I'll just write my questions here. So just for the sake of how a revision is done. Right? Okay. So I'll just ask you some small questions. Yeah. Let's do it here only. We don't need a lot of space for that. So yeah, just considered as a fast-paced, rapid questions kind of thing. Okay, so question number 1. You just need to, sometimes you need to answer as true, false. Okay, so my question to you is ki, parent of F. Okay, what is the parent of F, guys? So who is the parent of F? That is going to be B, right? B. It's easy, very easy, right? Okay. Now second question is, are NO siblings? Okay. NO are siblings, yes or no? So I will show you and then you tell me. NO are siblings, yes or no? So are NO siblings? No, guys. Siblings are not the nodes coming at the same level. They should have a same parent. Okay. So N's parent is L and O's parent is OM. So they are not siblings, right? So the answer of this question is going to be false. Ki N and O are not siblings, right? Now similarly, if I ask you this question, ki are A, B, C siblings? Are these nodes A, B, C are siblings? So yeah, the answer is going to be true. Reason being, look at the parent of A, B, and C. That is root. Okay. So yeah, they are siblings. Perfect. Okay. Now next question. Ancestors of K. So what are all the ancestors of K, guys? Ancestor means the nodes coming in the path from root to this particular node K. Okay. So K is here. Draw a path from root to this node K, and all the nodes coming in this path are of ancestor of K. Like ancestor means your parent, your grandparent, grandparent, then the grandparent. Obviously, root is everyone's ancestor. Am I correct, guys? Root is something that is every node's ancestor. Make sense? Okay. So yeah, for k, if I talk about, so draw a path from root to this node k. Now all the nodes coming in this path are ancestor of k, like root b f I, root b f I. Okay. So yeah, that is what is going to be my answer है कि root, उसके बाद b, f and I are ancestors. Right guys? Last but not the least definition, if I talk about descendant. So descendants are the nodes that are coming under you. Suppose I'm asking you what are the descendants of B. So the entire tree coming under B is going to be the descendants of B. Okay. So descendants of B are the nodes coming under B. That means Fij. Okay. Makes sense? So Fij is going to be the answer here. Perfect guys. Okay. So now everyone is clear guys. Anyone having any issues with these things? Are we 100% clear about these 5 definitions? Parent-child relation, sibling, leaf node, ancestor, descendant. Easy? Okay, clear? Okay, now with that, there are 2 more terms that we need to study. Okay. Right. And they are also like these terms, though kind of English words. Majorly, they were nothing but just English words. Okay. Now the next 2 terms that we are going to study are kind of a little technical things. Okay. So let's study them. They are not going to be very general English words, but let's study them. Okay. So the first one is, understand what I'm writing. Just a second. Okay. Suppose this is my tree. I once again want to give them the same name. A, B, C, E, D, E, F. Just a second. D, E, F. G, H, I, J, K, L, M, N, O, P, Q, R. Like, I don't know if I'm giving the same name or not. Yeah, I think I am. Perfect. So P, Q, R. Now try to understand what I'm going to write now is, once again, first of all, the definition part. Uske baad let's see the height of each and every node, guys. Every node is having a height here. So we are going to discuss about it. So height of, I'm not talking about the height of tree. I'm talking about height of a particular node. So understand this definition. Uske baad we will see. Height of node is nothing but the maximum distance between node to any of its descendant leaf node is known as height of that node. Think about it and tell me. Okay. So, right. So the maximum distance between node to any of its descendant leaf node is known as the height of that node. Like for example, guys, suppose I'm talking about height of B. So what are the descendant nodes of B? That is going to be J and K. The distance from B to this J descendant leaf node is 3. I'm considering the distance edgewise, guys, right? And the distance here is also 3. So what is the maximum distance between the node B to its any of its leaf descendant? That is going to be 3, guys, right? That is why the height of B is going to be nothing but 3. Now if you got this definition, can you tell me what is the height of node A? Yeah, what is the height of node A? The maximum distance between A to any of its descendant leaf. You need to pick that descendant leaf with which the distance is coming maximum. Correct? That is going to be exactly 1. Perfect? Okay. Right. Now quickly tell me what is the height of C? Okay. What is the height of C? So C. C ke baare mein if I talk about, so descendant leaves are G, to which the distance is just 1. Next descendant leaf is P, with which the distance is coming like 4. Next one is this one, the distance is 4. Next one is this one, the distance is 4. So the maximum distance between C to any of its descendant leaf is coming out to be 4. Of course, we'll go with the 4. Okay? So that is why the distance, the height of C is going to be 4. If you got this definition, can you tell me what is the height of root? Yeah, what is the height of root, guys? That is exactly 5. Matlab, if you got the point, just tell me yes or no, you agree on this point or not. Can I say height of a node is nothing but height of maximum of height of its child plus a 1? What do you feel around it? I am saying ki height of root is nothing but maximum of the heights of its child, maximum of them plus a 1. Agreed on this point? Okay. So yeah, this is how we play on it. Okay. So we can just simply get a definition from here ki height of a node is nothing but maximum of height of nodes childs, okay, and plus a 1 to this statement. Let's write it separately, plus a 1 to it. Perfect, guys. So I think this definition definitely makes sense. And why? Let's just understand the reason of it. Okay, like reason here is ki understand, guys. Okay, yeah, exactly, recursion again, recursion. Yeah, correct. Okay. So right now, we will not discuss about the recursion a lot more, but yeah, you are absolutely correct. Recursion is there. Okay. So like root is here. You want to find out the distance between root to its maximum distance between root to its leaf descendant. Now understand, guys, root ki leaf descendant will either lie in A's subtree, or it will lie in B's subtree, or it will lie in C's subtree. Understood the point? So now understand, if you got the answer of A, if you got the answer of B, if you got the answer of C, with which, can't you just guess maximum of them and just add up plus 1 to that so that you can get your answer? Make sense? Okay. So we are just saying the height of node is nothing but maximum of height of node's childs. Okay. And after that, the plus 1 to it. And it is true for any of the node, guys. I'm not just talking about the root node. It is true for any of the node. Like for example, will you agree on this point ki height of f is nothing but like let's talk about C here. Okay. So can I say height of C is nothing but height of G, that is just a 0, and height of H, that is a 3. Pick maximum out of them, that is 3, and to that add a 1. You got your answer. Correct or not? So this statement is true for any of the node, not for just of the root node. Okay, like it is true anywhere. Perfect. So with this point, one more important point is rising here. So can I say ki height of leaf node, we are considering that as a 0? Yes or no? Okay. Height of leaf node is getting considered as 0, right? Ki D, your height is 0, E, your height is 0. Now A, how can you find the answer? Height of this child is 0, 0. Maximum of them is 0. To that add a 1, get your answer. Okay, guys. So 100% clear about the definition of height. What the definition of height is? Maximum distance between the node and any of its descendant leaf node. Okay. Now, height of a particular node can be calculated with the help of height of its children. Okay, so find maximum of height of nodes childs, and to that add a 1, you got your answer. Like for example, if you want to know what is the height of root, so you will say, give me height of A, that is 1. Give me height of B, that is 3. Give me height of C, that is 4. Now pick maximum out of them, to that add a 1. You got your answer, and that is this one. इसमें से कोई सा भी, any one out of them. Okay, that is giving you 5. Perfect. Easy till now. Okay. Now one more word is there, and that is a little confusing word with height. If we are understanding height, so the next word is a little confusing. I don't know why. If the meaning is clear, I don't think there is any point of confusion. The next thing is even easier. Okay. No, size to bahut hi easier. The next thing is depth. Once again, depth of a node. A node, you are at how much depth? Okay. So understand the definition. It's very easy. Definition says distance between node, or I can say distance between node and, or yeah, distance of path from node to root. That's it, guys. That is what is known as depth of a node. Okay, so let's just copy the previous diagram and let's understand ki how this depth thing is different from the height thing. Okay, so you tell me, what is the depth of A? Yeah, distance between A and root node is how much, guys? Depth of A is 1. Can I say depth of B is also 1? Depth of C is also 1 then, right? Okay. Now quickly tell me, what is the depth of L? Okay, what is the depth of L? So L, The distance between root and this node L is known as the depth of L. Depth is defined as how far a node is from the root node. That's it. Okay, perfect guys. So depth of L is going to be 3. Correct guys? Okay. Now for this point, tell me ki if that is clear or not. Okay. And uske baad we'll do a discussion ki first of all to tell me, will you agree on this point ki depth of root is 0? Here the standard point is root. Okay, right? So the level here is root ki the distance of root to root is going to be 0. That's why depth of root is 0. Now can I say ki depth of a node is nothing but depth of its parent plus a 1? Think about it. Correct? Sahi. So these are the two important points that we can conclude, right? So like how can I, what is the depth of L? So I can simply say, can you give me L's parent depth? So depth of H is going to be 2 guys, and to that if you add a 1 you will get the depth of L. Got the point? Okay, now please understand the difference between height and depth. So can I say height is nothing but the, how far you are from the descendant leaf of yours, the maximum distance between you and your descendant leaf. Correct? That is what height is. Okay, we are calculating the height from the lower end, this from these ends, right? Like for example, if I talk about L's height, so look at L, the height of L is going to be 2 guys. Correct? If I talk about like height of C, so that is going to be 4. Correct? Okay, so you are calculating the maximum distance between you and any of your descendant leaf, right? Now depth is kind of just opposite. In depth what you are doing, you are calculating the distance, how far a node is from root. Like L is 3 distance away from root. Okay, like you are calculating the distance from the above side. Like according to me, well, that is just a simple definition key. Depth is, suppose a node is here, and the root thing is here. So the depth is nothing but this distance, the above distance, and the height is nothing but the below distance. Make sense? Okay, so depth is this, and height is kind of this. Okay, but if you don't want to generalize, I will not tell you to generalize this thing. Simple thing here is, you understand, just keep definitions in your mind guys. Okay, height is nothing but the maximum distance between you and any of your descendant leaf, right? Like for example, height of L is going to be, there is just one descendant leaf P, so height of L is going to be 2. This distance we are considering guys, this distance, right? Okay, now depth is nothing but getting calculated by keeping root as the reference. Okay, so depth is simpler, the distance of you from the root node as it is. Okay, so that's it, right? Like what is the depth of L? Depth of L is going to be 3 because it is 3 steps away from the root node. What is the depth of K guys? Can you quickly tell me what is the depth of K? So depth of K is how far you are from the root node. That is 1 step, 2 step, 3 step, 4 step. So depth of K is going to be 4. Okay, makes sense? Anyone having any issues? Perfect. Yeah. If you want to make conclusions out of it, go ahead guys, make. Okay, but I will suggest you keep just keep the real definition in mind. It will anytime clarify the doubt. Right? Okay, so makes sense? Like you can just see the difference. Depth of K is coming out to be 4, and height of K is how much guys? How much far this K is from any of its descendant leaf? 0, right? Height of K is just 0. That is the difference, right? Key height is nothing but this part, the below part, 0, and depth is the above part, this distance, that is 4. Correct? Okay, makes sense? Anyone having any issues now? 100% clear? Perfect. Okay, so are all these two terms also clear to you, height and depth of a node? Perfect. Okay, just for the last time, just to clarify the difference between both of the things, quickly tell me guys, what is the height as well as depth of the node I? इस बार दोनों बता दो, the height of I as well as the depth of this node I. Okay. What is height and depth of I? correct. ठीक है. Correct. Okay. So height is the distance of I with any of its descendant leaf node. So that is going to be just 1, right? And depth is going to be the distance between I to root. So that is 3. Okay? So height is 1, depth is 3. Perfect guys, simple. In depth, the reference point is this root. In height, the reference points are leaf nodes in your descendant tree. Okay, so that is the only difference. Clear? Okay. Oh, yeah. What happened with this tree? Yeah, now it's fine. Perfect. Okay. Now, guys, with that point, we are clear with this terminologies part, ki how these terms are defined. Now, it's very important ki all the things are clear, but how are you going to create this thing in your coding part? Ki, okay, like by definition, theory is clear to us, but how are we going to create this thing? Okay. So now comes to let's understand the structure of this tree, guys. Ki how we are going to create it, okay, and how we are going to define it in our Java language. Okay. So now comes the part structure tree. Structure of tree. Okay. The important thing to understand here is key. Okay. First of all, though, guys, the tree that we were doing till now is a generic tree. The diagrams that I was creating till now for you is a generic tree. We generally call it Henry tree as well. Why generic tree? Because look at it. This root node is having 3 childs. This A node is having 2 child. This F node is just having single child. So there are not fixed number of child for any of the nodes. That's why it's a generic tree. Any node can have any number of childs, right? Okay. Now the thing is ki generally questions out of this generic tree are not asked much. Okay. The questions come from the topic binary tree. Now we are going to start our trees topic from that itself. Okay. So we will do this thing. We will understand ki what is a binary tree. Okay, and that is what we are going to start with because that's easy to understand. And also binary tree and its variation are mostly asked. Okay, so structure of binary tree. Now tell me, by looking at this word binary, what is coming in your mind, guys? What do you feel around this word binary tree? Yeah, binary means bi means 2. So binary tree is a tree in which every node is going to have at max 2 childs. Okay, so in binary tree, each node can have at max 2 childs. Got the point, guys? At max 2 childs. Okay, yeah, exactly. Now by at max, what do we mean? Can I say at max 2 child means every node can have either a 0 child, it can have 1, or it can have 2. It cannot have more than 2. Got it? So that is what the definition of binary tree is. Every node is going to have at max 2 childs, and at max 2 means zyada se zyada do. That means 0, 1 or 2 is the correct thing. Perfect. Okay, right. Okay, now I will draw a diagram in front of you and you tell me is that a valid binary tree or not. Okay, so just give me a second. Let's keep it like this, simple. Okay, so these are the links. Tell me, guys, is this a binary tree? Is each and every node following the definition that you provided? Look at it. Correct? Okay, so look at it. This is a binary tree because every node is just having correct number of childs. Let's have a 25 here. Okay, like see, the number of childs for 10 2, the number of childs for 20 2, the number of childs for 15 just 1, the number of childs for 1 3 and 25 are 0. Got it? Okay, so this is a binary tree because each node is having at most 2 childs only. At most 2 means 0 1 or 2. Okay, like this would be incorrect, right? If we are drawing like this, so this is not a binary tree because now 10 is having 3 childs. Got it? Okay, so now this thing is clear, but now guys understand, can I say ki binary tree, like before going to the creation part, guys, it's understand ki okay, what is this? So can I say binary tree is nothing but a collection of nodes, collection of these circles, right? Binary tree is nothing but collection of your nodes. Okay, now if it is collection of nodes, it's important to define the node thing first. Now my question to all of you is ki inside the node of a binary tree, how many things do you want to store? Okay, suppose I'm creating a class whose name can be anything, tree node, node, binary tree node, any name. We are going with the name node. So class node. How many things you want to store inside every node? Think about it. How many things? How many data members are going to be there? Okay, perfect. Three. And what are these three data members? 12. Okay, what are these three data members, guys? Right? So these three data members are, first of all, guys, the data, of course, the value. You can name it value, data, anything of your choice. Let's name it as val. Of course, your data of each and every node. Then the address of a first child and second child. Every node can have at max 2 child. Suppose it is having exactly 2 child. Now we should store the address of left child as well as the right child. Okay, if there are 2 childs, now you can name them anything. First child, second child, left child, right child. The most famous name is left right. So I'm keeping the variable name as left right. Okay, now quickly tell me what is going to be the data type of left and right. Yeah, what is the data type of left and right, guys? So these are like storing the addresses of your left node and right node. Okay, exactly. That is why the data type of them is going to be node. Correct, guys. So this is how we define node of a binary tree. It is going to contain three things in it. That is val, left and right. Okay, val is the data and left and right are the addresses of left and right node. Of course, we need a constructor as well. Ki whenever we are creating a node, so the value we are providing is getting set it correctly. So suppose the value provided, we will just set this value in our object. This is done. So this is how we are going to define our node class. Okay, int val, node left, node right. Perfect. No, Tejas. Okay, we are going to just go in this direction. Like look at the links. Hai na? Link is from parent to child. Vice versa link is not present. That happens in graph. है ना? ठीक है? Trees में there are parent and child. So you are going from parent to child. You are not going vice versa. Okay. Hey guys. Now I would like to create some objects of this class, guys, so that the understanding becomes even more clearer to you. Ki how the binary tree is going to be created and matlab how the links are getting established. We are not going to think about the creation part right now, but just to give you an idea, I would like to create some nodes that will give you even some more clarity. Suppose I am creating node n is equals to new node 10, and then after I am doing node n1 is equals to new node 20, and then I am doing node n2 is equals to new node 15. Suppose I'm doing this thing, guys. So let's see what will happen, right? Okay. So with this line, what will happen? We all can say that a node class object is getting created. Suppose it got created at some address 14k. Now will you agree with me that 14k is nothing but the value of n, right? So n is equals to 14k. This node got created at some address 14k and n is going to have the value 14k in it. Now this node's value is defined. You initialize the value with the 10. Quickly tell me what are going to be left and right now. What will be the value present in left and right variables right now, guys? When I'm creating this object, I have passed the value as 10. So, okay. Now, what will be the value of left and right? That is going to be null. Exactly. Null and null. Okay. Now, with this second line also, what is happening? You are creating an object of type node class. Right. Suppose it got created at some address like 24k. Now, this 24k is nothing but the value of n1. And the val that we have passed is 20. Okay, so the val that we have passed is nothing but 20. Right. Now similarly with the third line also, what is happening, guys? You are creating a node. Okay, where suppose this node is getting created at some address 41k. Now this 41k is nothing but the value of your n2. Okay, and the value that we are providing here is 15. Correct, guys. Now tell me one thing. Till now I think everything is clear. This is not a thing that I'm doing for the first time. I just defined my class and I'm creating three objects of that class. This is my first object. This is my second object. This is my third object. Every object is containing three things in it: value, left and right. Okay, now everything is done, guys. 3 nodes are created, but tell me, is the data structure, is the information yet created? Can I say only the nodes are getting created till now? The links are not done. The links are not done. Now let's establish the linking part. The linking part is, tell me you got it or not. N dot left is equals to n1. Read this line and do the work. N dot left is equals to n1. What will happen? 40 n dot left means 14k dot left. Can you become equals to 24k? Yes, it will become that. And by this line, you are doing this linking, guys. Perfect. Okay. Now, if you say n dot right, can you become equals to n2? So by this line, what will happen? 14k is right is going to become n2. That means 41k. And by this line, you are doing this connection. So yeah, makes sense. This is how the connections are going to be built. Perfect. Okay. Right. But there is a note that I want to discuss right now. Guys, you don't have to worry about the creation part. Creating a binary tree is not going to be an easy thing if someone is providing you the data. That we are going to cover in our next class. So my note to all of you is कि right now, don't worry about creation of tree. Okay. So don't worry कि how a tree is getting created. Right now, what happens is कि what will happen is you will be given the root of already created tree and you need to solve a question based on it. Okay, so right now you will be given the root of already created binary tree and your focus should be on logic, how a question is given, how can I apply logic. So you will be given the root of already created binary tree to solve question. Okay, so this is what we need to keep in our mind right now, because binary tree creation is not like an easy thing. That itself is a complete algorithm. Okay, we will cover it, but in the next class, right? So understand this point. Right now, don't worry. But yeah, ऐसे something like this is going to happen. What is creation of node and linking part, and that I showed you in a small example. You can try it on your own. ऐसे like create nodes and then join links, and you can try it on your own. Okay, so this is something will happen with the help of complete algorithm that we will see in the next class. But yeah, if you look at the real picture, guys, this is to just a small picture. Okay, this is my binary tree. The real picture is nothing but this. This is what is happening in the reality. There are nodes, and nodes are having addresses of left and right. And with the help of that, you are, just talking about this entire information created. Perfect, guys. Makes sense. Okay. Just one or two more small questions, and then we are all set. So I would like to ask you some questions based on the structure that I created. I would like to grab it from here, and iske basis pe I'll ask you some quick questions. You need to answer them, so that just to make sure ki you got the understanding or not. Okay, can you quickly tell me what is going to be the answer of, let's not write SOPLN, ऐसे ही बता देना. Okay, chalo, let's write SOPLN. What is going to be the answer of n dot right dot val? Anyone? N dot right dot val. Exactly. Okay, if the structure is there now, you can just have a look at it कि n के right में उसकी value देनी है. Okay, but even if you want to understand it carefully, n dot right means 14k right, that is 41k. Now its value is nothing but 15, guys. Okay, so the answer here is going to be 15. Perfect. Okay, now my next question is SOPLN. What is n dot right dot left dot val? What is going to be the answer now? Yeah, n dot right dot left dot val. Little confusing. Do it. Exactly. Okay. If you write this line in your compiler, will the code even compile? You all are telling me the answer is null. Will the code even compile, guys? Exactly. No, code compilation is not going to happen, guys. Okay. We know this thing na, if you try to encounter property of null, if you do null dot something, you will get null pointer exception. Correct? Okay. Understand it with me. N dot right means 41k till now. Now 41k is left is null. Right? And if you are saying give me null dot val, that is a thing equivalent of null pointer exception. You can't access properties of null. Okay, so this entire thing is null, and when you are saying null dot val, okay, so that will give you null pointer exceptions, right? So don't, just take care of this thing. The same thing happened in linked list can happen here as well. You need to be a little careful that null pointer exceptions are not coming in your code. Okay, so this statement won't even execute because you will get null pointer exception. Make sense, guys? Okay, so this is the reality. But yeah, when we are solving the problems now, of course we are not going to write this much bigger diagram and then do our questions, then do our dry runs. Okay, we will just draw these diagrams, and इसके basis पे you should get a click that okay, there is a node whose data is 10, whose left is the address of this node, whose right is the address of this node. Make sense, guys? Okay, so this is the diagram that we are going to create frequently, not this one. This one is just for the sake of understanding. All the reality is this only. Correct? Okay, so till now, are we clear till now, guys? Anyone having any issues, please tell me. Okay, is the structure of tree also clear to you? A binary tree is nothing but collection of node, and we just understood how a single node is going to look like. A single node is nothing but containing its data, the address of left and the address of right. Okay, now the final thing I would like to talk about is, uske baad we'll definitely have a break and we'll do the rest of the things after the break. Is, guys, see, do we all know that these are just the names of the variables? Like, tell me, if someone is saying that I would not like to name my this variable as left, I would like to name this as chin2 and this thing as bit2, and now they are writing their code accordingly. They are just saying here ki n dot chin2 is equals to n1, n dot bit2 is equals to n2. So will they face any error? The answer is no. These are just the names, right? Okay, the only point is ki it's important to keep your names relevant, right? Like if you are just naming them with your name, so it is going to be a little confusing for the third person who is reading your code, right? So that is why name should always relevant. Okay, that's why I have named my class as node, although somewhere else you can see this name as tree node or some other thing as well. Does not matter. Then you are going to change your code accordingly. Ki, okay, tree node shall create an object of tree node. Everywhere the word tree node will come instead of node. Similarly goes with these data members variable names. Like the name of this is val, it can be some other thing as well. The name of this is left, it can be some other thing. Some people call it as first child, second child as well, but the most general name is left and right, so we kept it as left and right instead of any other name like chin2 bit2 or okay aise kuch bhi. Okay, because those are not very much relevant name. Okay, make sense? Perfect. Like Abhishek, understand ki suppose if this thing is like chin2 na, suppose this is chin2 and this is bit2. So understand there is a node in which three things are there: val, chin2 and bit2. Now how will you do the thing? You will just simply say ki n dot chin2. That will give you the value of this variable. Got the point? It's just about the name. Okay? So like the properties, like when you have created an object and you are accessing its property, so these properties are getting called by the names that you are providing here. So these are just the names. In my case, the names are val, left and right. So I'm writing n dot val, n dot left, n dot right. In your case, if the names are different, you can just go on with them. But yeah, generally to guys, the names are these. Matlab in 95% of the situation, if you are looking at a binary tree node, the names of the properties are going to be these. These are very much used. Int val, the node left and the node right. Okay, right? Perfect. Clear till now? 100%. So we are going to go with these names only. Make sense? Correct. Okay. Now the next very important thing that we need to cover is the traversal part, guys. Of course, whenever we are understanding a new data structure, it's very important to know how to travel it. So the next thing is going to be traversal in binary tree, right? But now, like we have done a lot of information, we have gathered a lot of information till now in today's class, okay? Because everything was a little theoretical. So let's do it after a quick break. Let's take a good break, and after that, we will do this traversal in binary tree. Okay, how can we travel a binary tree? Okay, and one point from this question and onwards, don't worry about the point how a binary tree is getting created. I've already told you we don't need to worry about the creation part right now because that is a difficult algorithm. We will cover that in next class. Okay, right now imagine a root of already existing tree is given to you and you are solving your question. Okay, so that is how we are going to proceed. Perfect. So it's 10:08 right now, guys. Let's take a break till 10:19. Okay. And after that, we are going to start our traversal part. Like Presi, it should be like this only ki class content, assignment and homework are quite sufficient. But if you have time, if you can spend time, okay, you can definitely look at the lead code questions as well. That will give you exposure only. Okay, that is also beneficial, right? So if you have time, you can go ahead with it. Otherwise, the class content, assignment and homeworks are enough. Right. I think Gargi, you will be directly going to the next module, right? Okay, ठीक है. With that, now let's start with this thing, traversal in binary tree. Now understand, guys, the thing that we are going to discuss right now is most important in this entire tree topic. Reason being, you will see कि if you have understood the traversal part carefully, how to travel a tree, then any of the question is not going to be difficult for you to write. Okay, so all of the questions will be doable if you know how to travel a binary tree, right? So now let's first of all understand. Okay, so traveling a binary tree, right? मतलब traversal of binary tree. Now there are two ways, right? The first way is the iterative, using a loop and create something with the help of that. The first one is iterative. Now the second way of traveling your binary tree is recursive. Both of them are of same time and space complexity, guys. Okay, you will understand this reason, but right now let's not go in that. Right now let's keep things simple. Just tell me, what do you feel out of iterative and recursive, which one is easier? Travel your binary tree out of the iterative and recursive way, which one can be a little easier? Think about it. Easy as far as the code is concerned, uske point of view se, right? So obviously the recursive code is easier, right? And it's easy to understand, it's easy to write the code. The iterative code is a little bit tricky. Now don't worry, we will do this thing in our next class. So right now let's keep it on hold because that's a tricky algorithm to understand. How to travel your binary using iteration, that is a tricky thing. And although, see, understand, if it is giving us any improvement in the TC and SC part as compared to the below approach, then it's of worth a discussion. But understand the point of guys, कि both of them are of same performance, space wise as well as time wise. So we will do this thing, but in the next class. All the entire tree topic is going to be based on majorly the recursive traveling because that is the easy way to travel it and it also has a nice performance. Okay? So we are going to understand this recursive traversals, right? Now let's try to do it. Let's keep this a small tree with us. Okay. Now right now, guys, understand my task is I want to write a recursive code that can help me traveling all the nodes of this tree. Okay, now I will be given with the address of the root node, that means the address of this node, and now I need to travel all of my nodes. I just need to touch each and every node, that's it. Okay, so for that thing I'll be writing a small code in front of you. Of course we will not get it by just the code, we will understand it, but let's see. So void, I'm just naming it as traversal, right? What I'm receiving is the root node initially, node. You can just call it node or the name of the variable. Like initially this node is going to store the address of your root node, right? Okay, now simple thing, understand guys, whenever I'm entering in this function, I'm already sitting at this node. Right now I'm sitting at this node. Now my task is to travel the entire left tree, and then my task is to travel the entire right hand side tree. So understand, if to the traversal function you are providing the root node, that means this. So you are saying, help me traveling this entire tree. Now to this traversal function, if I provide the node, this 20 node, so can I expect it to travel the tree under 20? I can, right? This is what recursion is. You keep faith in your smaller problems. Then only you write the code of bigger logic. Okay. So let's keep a little faith and let's try to write things. I am just telling कि ठीक है, node पे we are right now sitting. Help me traveling the entire left hand side subtree by doing this call. I'm going to call the traversal function by passing node.left. Right? Now